Right. Welcome, everyone. Thank you for joining us again for our monthly webinar series. This is a webinar series that is co-hosted between the Tennessee Urban Forestry Council and the University of Tennessee School of Natural Resources. We're very excited today to have Lindsey Purcell from LP Consulting Group to speak on tree pruning impact and response. Based on the registration numbers, it seems that you all are excited too. We're gonna have a big group here today, and we're so glad you're choosing to take an hour out of your day to join us. So real quick, I'm going to pass this over to Katie from the University of Tennessee for some info on CEUs and housekeeping.
Hi, everyone. Thank you for joining us today. If you are attending and you are hoping to receive ISA CEUs or SAF CFEs, please make sure that you've registered and you've paid the $10 fee. And also, please make sure your full name is showing in order to receive credit. We use that whatever name you have on Zoom to match it up with the registration, and that's what we send in for those CEU credits. So you can rename yourself by going down to the participants button, clicking it, finding your name, and there should be like three dots out to the side, and you click it, and there should be a rename option. And please rename yourself according to what name you used when you registered. And that's how, like I said, we use that to send those into ISA and SAF for those continuing education credits. If you are just a general attendee, no payment is needed and you don't have to do anything else. TUFC members also don't have to pay. That $10 fee is waived for them. If you have any questions during the webinar, please put them in the chat and we will have a Q&A session at the end of the webinar. And I think that's it.
All right. Thank you, Katie. Well, Lindsey, it's all yours.
All right. Well, thank you, Katie and Kevin. I appreciate the opportunity to present your webinar series. Thanks to the TUFC and UT. Always enjoy doing these and kind of spreading the love of arboriculture around the country. So thank you. I'll get right into it now, and hopefully everything works well technologically. But what I wanted to start with is basically we're going to talk about the pruning, the impact of pruning and the response of trees to pruning. Now, pruning's an important arboricultural practice that I think a lot of us understand as far as pruning goes, but I don't believe most arborists understand what the impacts are. Trees are a dynamic living organism that responds to external stimuli, and especially from our arboricultural activities. And they elicit some amazing responses in trees. And that's what I want to talk to you guys about today. So, anyway, what I'm going to talk about is those important biological considerations that are a result of pruning. I'm going to talk about each one of these items, such as the hormonal response, how pruning affects carbohydrate production and reserves, also biomechanical responses that we often don't think about, wound recovery, which I'm sure that'll be familiar with a lot of people. And I'll also get a lot of questions about scheduling pruning and the time of year, and I'll touch on that part a little bit as well. So one of the things that's important to realize that pruning does have a series of biological consequences. By pruning, especially when we're talking about live green tissue, removing that, we're removing leaf, the photosynthetic array, and also buds in the process. During that process of live green tissue removal, there's a loss of food supply and reserve capacity, especially in our larger woody pruning cuts. Sometimes, if we're looking at those larger cuts, we're talking about a potential change in plant form or morphology. And we especially see a change in crown symmetry when we're looking at creating clearance for our utility service providers as well. Also, by pruning, the tree is very strategic, and it still amazes me to this day how trees respond to pruning. But there's a change in resource allocation due to this intentional wounding from our pruning interventions. And basically, it's just an overall suppression of plant processes. The summary result of pruning, especially live tissue, is that whole tree processes are suppressed, and it creates sort of a stunting effect that's what I like to call just a whole lot of lesses. We have less shoots, which in excessive pruning, we could have less roots. We affect carbohydrate supply, less storage, less nitrogen uptake, and if done in excess or improperly, we can have some real problems. So let's go ahead and take a look at some of the implications of pruning in regard to plant hormones. Now, if you remember back to your basic plant physiology, hormones, or even human physiology, hormones are little tiny chemical messengers which have an amazing effect on plants, animals, and people. They're found in very small quantity, but they have a big effect or a big punch, if you will, when it comes to growth and other processes. Basically, all aspects of growth and development are regulated by plant hormones, and there's five major hormone groups that affect over 2,000 plant processes. Even just a very small concentration of these substances produce major growth changes. But we're going to keep it basic and just discuss the primary groups and the responses based on pruning. And this is our auxins and cytokinins. Now, there's a difference between plant hormones and plant growth regulators. Plant hormones are endogenous chemicals produced naturally by the plant, while plant growth regulators are what we call exogenous and applied to plants by humans, and they mimic the actions of hormones. But plant hormones and growth regulators group together chemicals that affect activities such as flowering, root growth, and the prevention or promotion of stem elongation. And as I mentioned earlier, two very important hormones affected by pruning are those auxins and cytokinins. And that's what I want to talk more about in relationship to pruning. So, what I'd like for you to do is think of branches and stems a little differently. Think of them as more of a connective tissue or a pathway or a highway connecting the roots and the crown as one complex circuit, creating basically growth control pathways. And these pathways transport food and water, as we know, xylem and phloem vessels, but they also transport these chemical signals telling the plant how to respond. Now, going back to auxins and cytokinins. Now, auxins cause several different responses in the plants. As we know, they create a response in the plant as a result of phototropism, or geotropism. But one of the more important things is regarding the morphology of the tree and promotion of apical dominance. So that's the tendency of the apical bud to produce a hormone that suppresses the growth of the buds below it on the stem. So if you look at auxins, auxins are manufactured in the canopy, apical growing points, but they actually are responsible primarily for root growth. Now, on the other hand, cytokinins are produced in the roots, and they have an effect on canopy growth. So cytokinins stimulate cell division, and we can also see them included in sterile media used for growing plants from tissue culture. But in our application here, cytokinins affect cell division, which in turn affects plant growth by stimulating lateral buds, yet inhibiting the aging of other organs and plant tissue. So it's a downward flow of this auxin that creates a pathway from the terminal bud to the root tips. And so as the cytokinins are produced in the roots, they will move upward, promoting the activity of the lateral buds, while the auxins produced in the shoots in the apical meristems actually inhibit cytokinin activity, which gives us that apical dominance. So one is basically stimulating growth while the other one is inhibiting the growth. So it's that process we need to think about is how roots and shoots are managed makes a difference in how the tree responds. For example, excessive pruning, such or topping, can have a major impact on the roots because that auxin is necessary to stimulate root growth. On the other hand, if we have damage to the roots, for example, through construction damage, we are affecting the quantity or the amounts of cytokinins that are moving upward in the tree that will cause a cessation of growth or a suppression of growth in the crowns. So this hormonal response is a very delicate balance of chemicals where our outside interventions, either through pruning or root disturbance, can have an overall effect on the tree. So when we let's think about topping, think about those general effects of pruning from that earlier side. Now, put into perspective the pruning practices relative to loss of food production, storage reserve. So there's an incredible demand from a systems level on the tree, both from root and shoots. And, this is a typical picture that you would normally associate with topping, but it comes in many forms. Actually, shearing or rounding over is topping as well. Basically, it's internodal pruning. This is actually, you wouldn't know it from the picture, but a linden tree made to look like, well, a cone head or of some sort, if you will. And then the picture on the right there, you actually see a live oak, which is found in Florida that had been totally abused, along with the crepe myrtle beside it, which apparently somebody was very angry with and pruned it as such. And then also, even the landscape management crews participate in this process, or at least what they can reach. This is another live oak in Florida that I was able to get a picture of, and you can see that, again, this is topping or internodal pruning, which will result in a stimulation of a lot of sprouts. So the consequences of topping or excessive pruning in the crown includes these epicormic sprouts that develop. And as we know, they are weak attachments to the xylem level or xylem layer in the tree. So this excessive sprouting just is basically the response from stimulation of these dormant latent buds. So we get this proliferation of sprouts as a result of this truncated stem and accumulation of resources. So looking at it from a more graphic perspective, so once you cut the top of the tree off or cut that large pruning cut, basically the auxin transport is disrupted. So the apical meristems have been removed, and as a result, cytokinins kind of get lost and accumulate at the point of this truncated stem. So it's like, what do we do? Well, these latent buds are stimulated by this accumulation of hormones in this particular area. And this is why we get this huge proliferation of new stems or new sprouts as a result. And the problem is this shoot expansion is really at the expense of two things. One, high demands on the tree for resources, including water, but also it will affect root growth as well. So and then of course decay ensues because of this large wound. So what we're doing is basically putting the tree into this hormonal frenzy as a result of this severe or excessive pruning that severs the pathway in the tree with the shoot tip removals. So, and here's a good example of a tree that was in not too long ago. And you can see where this maple tree had been topped. And as a result, there the decay resulted basically as a result of excessive heartwood in relationship to the amount of sapwood. But all those larger limbs there, those are about 3.5 inch to 4 inch branches that are actually sprouts that are have been allowed to grow. And the problem is they're high risk issues because they're weakly attached to the xylem layers and are very prone to failure. So that's the primary issue that we typically see or response from the tree in that situation. Sometimes people just do it intentionally. So these are some black ash that actually found in Texas. And you can see where the owner actually just basically pruned those down to stumps or stubs, and to allow what you see there in the middle image, kind of just a topiary tree. But you take a closer look at those, you can see those are just little sprouts that have been allowed to grow. And they're epicormic sprouts from latent buds that have just come out from underneath the bark layer. Problem is, that's going to be one of those things that doesn't last long because, again, huge amount of resources are demanded by the tree in response to trying to reiterate what it's lost. And so, going back almost 2 years later, you can see it's just a mess of sprouts as a result. And actually, I just went to look at these two ash trees this past year, and they're actually gone now. So they died as a result of basically uh, a deficiency in carbon availability to keep the tree alive. And speaking of carbon, I want to talk about the pruning effects on food production as well. So the availability of resources to the tree are essential in response to mechanical wounding, mainly because it needs those resources for recovery. So pruning live green tissue challenges the allocation strategies internally for the tree. And what it comes down to for trees is it's all about that carbon. Um, when it comes to tree growth and survival, but not just surviving, but thriving. Carbon is a plant's currency, and growth is funded by carbon assimilation and also the ability to have storage locations within the tree. As you can see on this graphic, basically about 50% of the carbon is stored in the trunk, 25% in the roots, 20% of the branches approximately, and 5% in the leaves. So photosynthesis, as we know, creates those carbohydrates and releases that energy to the plant for different uses through respiration. But it's also important to recognize that there's a difference in carbohydrates as well. And I'll talk more about that in detail here a little later when we talk about pruning timing. So we can kind of group our carbohydrates into two different categories: structural carbohydrates, which is the SC, and non-structural carbohydrates. And structural carbohydrates are what creates the building blocks for the tree and are important for creation of lignin and cellulose. While non-structural carbohydrates are kind of like the ready to eat meals. It's the carbon reserves used by the tree to fund future growth and life processes such as new leaves, formation of buds, flowering, and things like that. When we prune this live tissue excessively, especially, we're depleting that tree's ability to create carbohydrates through photosynthesis, but we're also removing storage capacity. And the overall result is a carbon deficit for the tree, which is very important in survival, as we know. And that's what I always get this question: why is my tree dying? Thousands of times over the past 20 some years of teaching and working in extension. But through my literature reviews and personal experiences, really we can suggest that tree death and decline could be attributed to basically two primary issues. It's carbon starvation and hydraulic failure, either alone or in combination. So when we talk about hydraulic failure, we're typically talking about drought, which most of the nation right now is experiencing a serious drought, which will probably have legacy effects in subsequent years. But moving more towards pruning, it's that carbon starvation. By having a reduction in carbon resources available, we have reduced respiration along with those low reserves, and basically the tree goes into basically life-saving mode strategy. And what it truly affects is the low non-structural carbohydrates that leads to that decline. And then, but usually it's secondary issues that are blamed. But typically, if you get to the root of the issue, it's lack of water and lack of food, basically, that's causing that tree to die. Now, when we get to the bigger trees, typically we think more about pruning when it comes to those early established trees and younger trees. But the older trees are very important to think about pruning dose. It's especially on mature trees. And so when it comes to that, if at all possible, don't remove any of the any limbs or live green tissue unless absolutely necessary to meet climate objectives, especially those older shade leaves. Typically, these are located on the interior of the crown. In fact, really, no pruning should occur inside what I call the pruning zone. And when I look at when I'm talking about the pruning zone, I'm talking about this area out in here where we're looking on the periphery of the tree. Nothing should be going on the inside of the crown because those are the shade leaves that actually are doing the heavy lifting, especially during this hot, dry weather when the younger, newer shoots on the out periphery of the crown are actually shutting down. So those heavy pruning doses, especially these older trees, also stimulates the production of epicormic sprouts. Again, which is like throwing gas on a fire, increases water demands on the tree, and this is where stress increases as a result of that. So consequences of even moderate pruning on mature trees causes the same response, reduction in carbohydrate levels. Root health is affected as well, and then that excessive like epicormic sprouting. So one of the most important things that you can do if you're pruning, especially large, more mature trees, is take a moment to do a health assessment on that tree. And that best way to do that is just grab a couple of branches and look to see what the growth increments are on that tree for the past year, 2 years, or 3 years, to see where those terminal buds were located and find out just how the tree is doing. And that should have a major part of your decision making is and what levels of pruning, as far as pruning dose, you can actually enact on the tree. All right, let's move on to loss of balance. So, as far as our impact of pruning, so the shape or morphology of each part of the tree is determined by adaptive growth in its environment, naturally speaking. So, in the built environment, we manipulate that morphology through pruning. Now, when it comes to pruning, we often talk about what's been removed through the dose or number of cuts. But when it comes to stability, we need to go back to what's left on the tree, which is just as important as far as what is removed in relationship to stability and potential for failure. So, crown morphology plays a major role in response to dynamic loading, especially from wind loads. So pruning interventions can manipulate the bending moment of the tree, and through pruning, depending upon the size of the cuts, we can either improve stability or destroy it, depending upon the intensity of the pruning. So it's important for us to understand the physics of the tree, understanding live crown ratio, which is the ratio of the live crown in comparison to the overall height of the tree. Also understand by pruning or through crown raising or what we call pruning for clearance, we're raising that center of mass. And this is where the majority of the load will impact the tree. And by raising that center of mass, we put an increased load or bending moment on that lever line. So understanding how loading forces and energy affect that tree overall biomechanically is very important for manipulating likelihood of failure. As I mentioned, most of the time our loading comes from wind energy. So excessive wind can be attributed to the primary cause of most tree failures. And wind loads are typically periodic and produce a very complex sway motion in the trees. And that's why it's important to have good taper and response growth. But in order to remain a stable, sustainable structure. But when trees experience excessive wind loads, we got trouble, especially on those trees with poor structure, as you see in the image here. So this is one of those codominant stems that we see. You can see the bulging on the sides of included bark and the decay that was present there. But as we know, failure occurs when loads exceed the carrying capacity of that tree to experience those loads. And strength has many variables. So it depends on not just taper, but there could be imperfections in the wood or the branching structure. And bigger trees, bigger parts, that's bigger load on condition of concern or defect, as you see in this. So, as we see this codominant stem, oftentimes I say it's not a matter of if it fails, but when it fails. And that's usually when failure or load exceeds the strength of that tree. So as I mentioned earlier, wind energy or excessive wind energy is what will have an impact on that tree's ability to withstand those loads. And when we remove large amounts of live green tissue, we are also having a negative impact on the damping effect of trees. When we talk about damping, basically, trees work very efficiently in dissipating those wind loads. And how they do that, if you watch the tree in the video here, or just go out on any day where it's kind of breezy, and you'll watch the leaves actually change shape and which reducing that drag coefficient on the branch itself. And then watch how the branches sway and interact with each other. It goes from very, very dynamic and active on the outside of the tree. And as you move through the branches into the primary limbs, into the trunk, and into the roots, basically the stem and the roots and the earth are damping that energy or reducing the impact or dissipating that movement. So we get a minimal sway response. It's that sway response, harmonic sway that typically results in disaster for the tree. But if we start removing a lot of these live green branches, we're also removing that tree's ability to dissipate that wind movement. And this is where we typically run into problems. So damages by topping, you can see this is actually a live oak, again down in Florida. And because you can see right where the pruning took place, it's like, oh my gosh, can't believe they did that. So these large branches are starting, actually epicormic sprouts that are maturing now. So this is where we have the weak attachment and long lever arms. And by removing these interior branches and removing the major structural branches, we get this response that's going to be more likely to fail as a result of that. So you can see where these branches were pruned, and these are just long lever arms with poor attachments, and any type of bending moment that will exceed that tree's ability to remain attached is going to result in failure. And going back to our center of mass, if you remember what I was talking about earlier, lion's tailing, which seems to be becoming more and more prevalent in our industry, is maybe just as damaging, if not more, than topping. So I mentioned earlier, we're actually changing or shifting the center of mass in this process. So you can see where all of these interior leaves have been removed. So now our center of mass has gone from about here to now we're looking at about here. And think of the stress and strain on these attachments. And this is a poor structure to begin with because you have multiple leaders, and which means typically poor attachments. But here's our lever arm. But the tree's just basically one big lever arm. And each one of these has extended center of mass. So that means the sway motion is going to be huge on this attachment. So whenever I look at something like this to determine its likelihood of failure, I go right to the attachment here and determine, can that attachment sustain this long lever arm as a result of removing that damping effect that those removed branches once had. And then, of course, looking from a health perspective, we can see that this is that same tree 2 years later, and you can see where basically we got all of these sprouts starting to emerge as a result of basically trying to reiterate itself, recreate, if you will, the branches that were removed in that process. Here's 5 years later. I've been watching this tree for quite some time. And thank goodness they stopped torturing it. And now the branches are starting to fill in. So hopefully that will keep the tree from failing. So as you can see, basically any alteration to the crown can result in a response from the tree. So we need to really pay attention to crown symmetry, especially with aggressive pruning objectives are required, and that's typically uh, when we look at utility pruning and vegetation management. So that pruning modulates the morphophysiological response of that tree, and we need to make sure that we maintain apical control and apical dominance in order to preserve that structurally sound tree structure. Here's my truffle tree, if you will. The excessive removal of lower branches. Here's our center of mass way up here. So you can imagine what the bending moment is on this tree and once it catches the right wind. So that's going to be problematic later on as well. So we want to make sure that we choose the right cuts in the right location, either removal, reduction, or heading cuts where necessary in order to maintain that good central dominant leader system and pay attention to structural pruning to improve good branch attachments. All right, let's think about recovery. So we've been discussing a little bit about tree response to pruning. Now I want to talk about how the tree recovers from this intentional wounding and how they actually recover from those cuts. Now we'll do just a bit of review. As we know, CODIT's one of the most famous acronyms used in our industry. It represents compartmentalization of decay in trees. There's been, I will say, there's been discussion of a shift in that acronym where it's a compartmentalization of damage in trees. So you may see both in future lectures and discussions. But it was a defense model or strategy that Dr. Shigo introduced to us back in the late 70s. And it's a physiological process which creates a chemical and mechanical boundary that to resist wood decaying organisms, primarily fungal organism. So what it does is it creates a separation of healthy tissue and infected tissue by reaction zones and barrier zones. It's also a model that's easily understood by our arborists as far as a wound response strategy and should be a consideration in our pruning activities. So I did a pruning wound trial at Purdue several years ago, and based on size and resources and developmental age, would have an impact on the effectiveness and speed of the occlusion of that wound. And if this is an 8-inch red maple, and you see with almost a year that wound has been almost completely closed, and that's exactly what we want to see in the pruning process. And it's basically not only just a function of capability and species, but also the relationship of heartwood to sapwood will have an impact as well. In fact, there'll be an article in TCIA magazine in November that I wrote on pruning implications relative to heartwood and sapwood ratios. Also pruning wound size, but also the type of cut. You can see pruning wound size does affect the cut, but also making sure we make a good cut relative to the branch collar. See, this was an image shared with me by Dr. Dewey Siepken at the University of Hamburg, who did thousands of pruning cuts and trying to determine what is the best type of pruning cut for the size of branch. And you can see basically the larger the cut, the larger decay. And that's typically a function of the amount of heartwood in relationship to sapwood. On the left, you can see it's also right borderline flush cut, if not. But on the right, you see a good branch collar cut, which restricted that decay to the branch protection zone to allow those internal phytochemicals to act appropriately and try to reduce the amount of movement of decay and progression of decay into the tree. So when it comes to coat it, actually, some trees are just better at the process than others. And the essential reason for this variation lies in wood structure. And as I mentioned, basically the proportion and amounts of parenchyma cells, and also vessel diameter plays a role in that as well. So larger vessels or ring porous trees are less effective, it seems like, than our diffuse porous. And that's anecdotal. The research and literature reviews that I've looked at internationally typically leads to a dead end, but it almost seems like that's kind of where it lies is basically vessel construction as far as their effectiveness in pruning. So, some weak compartmentalizers, and you may recognize them to be that as well, include like ash, birch, poplar, willow, a lot of fruit trees, also some evergreens such as spruce and hemlock, where more effective compartmentalizers include beech, elm, hawthorn, honey locust, hornbeam. Even within the quercus species, and also maples as well. Um, we can't really make the distinction as we have in the past. Well, softwoods are poor compartmentalizers compared to hardwoods, and that's sort of a misapplication of that information. They both do it. Some species within that genus do it well as far as compartmentalization, and some don't. So again, I think it comes down to looking at vessel arrangement and understanding their vascular arrangement, whether they're ring porous, diffuse porous, or even semi-diffuse porous, to determine the speed of that occlusion, which affects the size of branch. So when we think about this, when it comes to recovery and wound occlusion, we need to think about those essential parameters. So it's the diameter of the branch that we're cutting, the age of that branch and health of the tissue, and also the tree's genetic ability to compartmentalize those wounds. So it really depends on the parenchyma cells. And the reason I keep mentioning parenchyma cells is it's going to have a huge impact on timing and the availability of stored materials. We just talked about that too. So, it's all kind of coming together here. Does it have enough carbohydrate reserves in order to facilitate that coated process? So trees will recover from those pruning wounds or any mechanical damage if they have the time, the energy reserves, and the genetic capacity to compartmentalize. So, all right, Lindsey, what does this all mean to me? Well, when it comes down to it, based on literature reviews and my research as well, 2-inch size cut should be the maximum on trees that are considered poor compartmentalizers, and 4-inch on good compartmentalizers. Not to say that you can't go larger, but remember that they could have some negative implications as far as recovery time. So when we look at larger cuts, instead of doing those removal cuts, we might want to think of a progressive reduction of those branches instead of just a huge trunk cut. So I like to advocate for what I call sessional pruning, with maybe successive reduction cuts over a period of 3 to 5 years, rather to allow the tree to recover before we make those large trunk cuts, if we have to at all. So also consider the timing. So we want to make sure that we are doing this pruning, especially large branch cuts, during the active growing season. So this is what I want to talk about, is timing, which seems to be so critical for that tree's ability to compartmentalize. So the research that I've seen indicates that timing impacts that recovery process and the tree's ability to compartmentalize. So this is a little bit heady material, but it's so important to demonstrate these responses based on these episodic growth patterns. So where we got dormant pruning, now everybody thinks that dormant pruning is such a good thing. Well, it can be, and it's still used today, and applied properly, it's very effective. But Shigo introduced basically dormant pruning based on Some research done by Ashkenazi, which was a cherry tree farmer from Russia, actually. And he described what we call a modulation of potential energy within a tree over the course of a year. Now, Shigo's model suggested that potential energy rapidly declines during leaf formation and then recovers over time afterwards. So, as you can see in the graph there, so which kind of makes sense, as the tree is expending these resources for leaf flush, it's going to start creating a deficit for you with or an overdrawn bank account, which indicates sort of a weak moment for the tree, which means less healing, less energy available. And this certainly supports dormant pruning. Now, later on, Kozlowski and Pilardi came up with what I call the Kozlowski curve. Now, the growth cycle that Kozlowski shows us indicates that cell activity is at its greatest level from nearly all components of woody structures during the growing season, especially during these summer months. Also, remember that there's less activity, as you can see in the graph there, during the cold winter months. So this actually contradicts what Ashkenazi's curve reveals and supports pruning that is optimal during the summer months, especially in the temperate zone. Now, the researcher by the name of Gunther Holt also found that the non-structural carbohydrate pool actually increases during the spring and early summer before kind of stabilizing in the late summer and into autumn. So as a result of that, between Hoke and Kozlowski, it kind of says that, hey, we should be doing pruning basically during the growing season. And key themes there is one, we have this increased pool of non-structural carbohydrates, which facilitates the coda process. Also, parenchyma cells are more active during this growing season, which facilitates a faster occlusion of that wound. And basically an overall improved response to pruning. And also, again, back to vascular arrangement, species with larger vessels, such as those found in the early wood of ringworm species, they basically have no conductivity until the new xylem is produced in the spring, which creates an even greater demand on the tree at that time, especially early spring and when it's dormant. So again, that supports the pruning during the growing season to facilitate better recovery, but also less impact on the overall health of the tree. So there's a lot of research on that that's available, and I find it fascinating that it kind of contradicts our norms or accepted practices of dormant pruning. But again, we got to look at dormant pruning as a effective, especially when we talk about pathogen transfer with some of our diseases that we're dealing with today. So when it comes to pruning intervention, obviously compartmentalization of wound and wound wood development are important. We found that through that research, necrosis is lowest after mechanical wounding at leaf emergence. Wound wood thickness is increased post leaf emergence. Growth is maximized. Wound closure is fastest if pruning takes place during the growing season. So I kind of got ahead of myself there a little bit, but this is what the research has taught us. So I think it's important to maybe reconsider or take a look at your pruning timing and scheduling based on the biology of the tree and how it's going to respond to that. So also one last thing on timing, late season pruning in particular. When it comes down to tree health and to manage that tree, you got to manage its reserves. And pruning trees, as we mentioned, changes a partitioning of those reserves. So some woody sites will appear, some will disappear based on pruning and timing. And canopy size or crown size control is one of those major purposes of summer pruning to meet client or tree owner objectives. However, when we reduce that crown size by removing live green tissue, We also, it results in less light interception, consequently decreasing that photosynthetic efficiency in carbohydrate production, which leads to that imbalance of carbohydrate supplies, especially when we're talking about late summer like September. So we want to be cautious with and think about the developmental age of that tree as well, but also the timing of that pruning. So there seems to be appearing a sweet spot, if you will, for pruning, timing our pruning, if we're looking at isolating biology of the tree. So just in closing, a few more comments here. I'm about out of time. We're ready for Q&A. But make sure you prune with a purpose. And if you're familiar with the BMPs and standards, um, we're changing our pruning to be more objective based, pruning with a purpose, and also being prescriptive in order to achieve client goals and meet client needs, yet be considerate of the biology of the tree. And there's a lot of interest in prescription pruning right now that seems to be working very well to meet both of those demands, because it is very difficult to balance the mechanical demands or how much to prune with the biological consequences. So how much can we prune without compromising tree health? So that's basically what I've been discussing, is here's what we need to consider so that we don't further stress the tree with our interventions as well. So I like to think, kind of like to think like the dude, abide by the physiological demands of the tree. So tree care should consider the biological needs, not just the business needs in that pruning process. So just finishing up, I'd like to give some attributions here to some rock stars that have contributed to research and my progress in understanding this seemingly simple arboricultural intervention, but we're still learning more and more about how trees respond. So a lot of this information has come from my book, which is available now through Waveland Press. Shameless plug here, I know, but if you want more information on what I've talked about, it's summarized in more detail in the book. So I think that's just about it. So, yeah, if you have questions about this program today, or just want to learn more, you can give me an email or check out my website, or give me a call, and I'd be happy to answer those questions. So hopefully that helped your understanding of response to tree pruning.
Right.
So
Thank you, Lindsey.
back to you guys.
Yeah, that was really fascinating and informative and cool. And I'm sure we have lots of questions to get to. And oh, I did want to say thank you for the Big Lebowski reference. Any
I love
presentation
the dude.
that can fit that in is good by me. So yeah, I'll pass this on to Katie to facilitate the Q&A. I know we had a lot of questions submitted in advance. If you have a question that you haven't asked, go ahead and put it into the chat, and we'll get to what we can by the top of the hour, and then revisit things. So Katie, take it away.
All right. So I'm going to start with, like you said, those questions that were submitted in advance. This one asks, do woody bushes react the same as trees to pruning?
Yeah, very similar. One of the most important functions, they all contain parenchyma cells. There's basically other similar. We have the two primary parenchyma cells and sclerenchyma cells. But parenchyma cells are what are primarily responsible for healing or repair, and they're able to divide into a number of differential cells that plays an important role in how the tree or bush or any woody structure heal itself after a wound. So once those parenchyma cells are exposed in the wound, then magic takes place and the process of coated basically starts as a result of that mechanical damage. So yes, they're very similar.
Next question. How can professional urban foresters manage articulate, and improve outcomes for trees regarding pruning when there is a lot of volunteer enthusiasm and energy, but not a lot of understanding of arboriculture or pruning techniques?
That's a great question. And I've traveled around the country the last few years. I'm doing this for a lot of communities and even nonprofit organizations. And really, what it comes down to is consistency in our arboricultural literacy and our ability to communicate proper pruning process. So it's about a consistent message and training on pruning, which follows the BMPs and standards, and that's a great start. So I have several videos on my website that are free that people are using for training, very similar to one I did today. And again, creating that consistent message using the current practices and terminology, and following the BMPs and making sure we stick with those.
In the desert Southwest, probably only on certain species, making the final branch removal cut causes dieback a quarter of an inch, or at times quite more below the retained collar. What would be the reason for this, and how could it be avoided or mitigated after pruning?
Oh, great question. And I've seen this a lot, not just all basically anywhere there's pruning on woody plant material. So it's common to have lower branch color necrosis, even if, and what it has to do with the angle of the cut. So we're very concerned about identifying that branch bark ridge and branch collar. Sometimes that branch collar it's hard to distinctly defined. So oftentimes we'll make more of an angled cut. And what we're doing is actually creating a stub cut. And so we in order to reduce that, we need to have more of a flatter cut, which also is the smallest, more small wound, with less live tissue exposed. And I think you'll find that you won't have that lower branch collar necrosis. Dr. Dewey Siepkin, in his book, The New Coda Principle, goes into a bit of detail in his research on those pruning cuts. So I think it's about angle, creating a more flat cut outside that branch bark ridge and branch collar.
For removing an 8-inch diameter branch, you know that depending on the climate, it will probably not close the wound within the lifetime of the tree and thereby introduce decay into the main trunk, but you must remove it anyway. Therefore, is it better in this case to leave it as a large branch stump rather than the usual cutting um, next to the branch bark ridge and the collar?
Yes, and sometimes heading cuts are preferable to trunk cuts. If you can prune, basically what you're doing is buying time for the tree. You have these large trunk cuts with a significant amount of heartwood in comparison to the sapwood, then you're going to get decay there. So, and I've got several trees in Indiana that I'm working on studying how that response. And oftentimes, when we do a heading cut on a large branch, we'll get a proliferation of sprouts, which brings resources to that cut. And sometimes they can compartmentalize. But even if it doesn't, you're still buying time on that trunk before you have to make that final trunk cut, which that's usually the kiss of death for the tree. Then we're introducing decay into the primary stem, and just goes south from there. So, I've been criticized for heading cuts, but look at it, folks. It's in the standards, it's in the BMPs, and it's good practice where it's necessary. But that's certainly we not something we want to do a lot of on a tree.
Why do so many of the local tree services like to, quote, clean up the inside of the tree almost to lion tailing while limbing up the trees too high?
Oh man, that's I've been seeing that more and more, and I'm not sure if it's a function of filling up the chip truck or they just don't know what to prune. And by removing those interior shade leaves, you're really doing a disservice to that tree physiologically. As I mentioned earlier, when it gets hot and dry in the summer months, that new growth actually shuts down. And it's those interior shade leaves that are doing all the photosynthetic activity and creating resources for that tree. And also, again, it changes the dynamics of that tree biomechanically. So, why they're doing it, I think it's just misinformation or lack of information. But the pruning zone is on the outer periphery of the tree, and no pruning should actually be done on the interior unless we're talking about broken or damaged branches or crossing branches or what I like to call non-beneficial plants parts. But yeah, I don't know why. I'm carrying that torch though, hoping to educate more people on not to do that.
Can it be said that a tree's strength to wind damage reflects the natural annual wind loads and not those the tree has not been exposed to?
Can you repeat that again?
Yes. Can it be said that a tree's strength to wind damage reflects the natural annual wind loads and not those the tree has not been exposed to?
Well, that's just basically a function of response growth. Trees will react to normal conditions. So as a tree's moving, branches are moving, and every year it's basically working out. So it's that movement that actually stimulates growth, and especially in the form of taper and branch and response wood, especially on angiosperms. So as they're exposed to those loads, and as long as they're not excessive, then they're going to increase their taper and diameter, and that will help reduce likelihood of failure.
Can you address how to work with a tree that has been topped, specifically crepe myrtle?
I'm not sure you could do a lot with crepe myrtles. Now, the other trees that are topped, well, I guess even crepe myrtles if they haven't been touched for a while, but we basically manage topping sprouts sort of like storm damage. And we talked about the rule of thirds where we want to remove a third, reduce a third, and leave a third alone. And then over a period of time, we'll start selecting those sprouts which we'll want to cultivate. And they can eventually become well attached branches, of course, depending upon the species and location of that, but they can be managed. There's some information on my website about talking about storm damage recovery and that rule of thirds, also in the book as well.
What are your thoughts about, I think it's pollarding trees like they do in Europe?
I mean, it's acceptable pruning practice, but once you start it, you're married to it. It's got to be done annually. Not a big fan of it aesthetically, but it has a place, and it's certainly a pruning according to standards and best major practices. But again, it has to be done correctly. And topping isn't pollarding. I think that's confused a lot. But it certainly is acceptable practice as long as it's done correctly.
How much variation is there in recommended timing of pruning among different tree taxa, say family or higher classification?
Well, we really need to look at our genera, not just that, but also species. As I mentioned earlier, timing and pruning, we really need to go back to the woodworkers, guys that do the woodworking know more about wood anatomy than any arborist will ever know. And that is where we look at the vascular arrangement of the trees. It's not going to depend on the genus or species as much as we're looking at the vascular arrangement. As I mentioned earlier, ring porous versus diffuse porous. I think that's going to play a major role in the timing of pruning, especially if we're looking at the edges of that sweet spot, in earlier spring and later in the summer.
Just a few more questions here. During the compartmentalization and wound development, This is a very delicate time of recovery for the tree. What are the odds of the tree developing a disease in this process, like when a person can develop an infection after being cut or wounded?
Well, a lot of that has to do with, again, that tree's ability to compartmentalize genetically, the age of the tree, and the resources available to it. And remember, once a tree's wounded, either through pruning or a string trimmer or a car hitting it, the race is on. So those phytochemicals are thrown out into the air. It's like I'm wounded, and we got insect issues, but also there's all kinds of spores that are going to land on that tree and insert their hyphae, and the enzymatic activity begins of decay. Now, the race is the tree's going to occlude that wound and shut off that process. Now, on larger wounds, I have seen some success, actually experienced some really good success on larger wounds. If you catch it, I actually had 2 or 3 locations where a car hit a tree, knocked off a pretty big chunk of wood or bark, exposing the cambium tissue, covered it with black plastic, left it on for a year. I was amazed at the amount of wound wood that developed as a result of being covered. So, what it shows is that my wife is a nurse practitioner, and she's always saying moist wounds heal much quicker and effectively than dry wounds. Same thing goes for trees. If we can keep them covered, that gives a longer period of time that those parenchyma cells are alive and active to create that wound wood. So it's a kind of a delicate timing consideration, but there are certain practices that does help.
Okay, just two more. Can you address how detrimental pruning may be on newly planted trees?
Oh, pruning's not detrimental at all to newly planted trees. In fact, it's highly encouraged, because that's the best time to actually create a good central dominant leader system, and also get rid of some of those clustered branches that we often see. Remember, nurseries are selling crown, canopy, lots of green. And as a result, oftentimes we see less than favorable branch structures. So pruning is fine. We just don't want to be excessive in removing a lot of light green tissue, but let's at least start the process during that time. And there's not a problem with that as long as it's maintained properly.
And one person asked if you could show the credential page with your email and website again.
Oh, yeah, I think so. That one?
Yes, I believe so. Yes.
All right. Well, thank you, Katie, and thank you, Lindsay. We're a little past the hour, so we are going to end things. But thank you all for being here and submitting questions as well, being engaged. Um, Real quick though, we do have one more webinar left this year, and so next month we have wood decay and living trees. And so we will have Andrew Lloyd from Bartlett Tree Experts joining us. And then in November, for those of you who live in the region here in Tennessee or surrounding states and want to join in person, we have a conference November 14th and 15th, with a really robust lineup of speakers. The second day, we have workshops. We have an urban wood use workshop, developing a plant healthcare program workshop with Rainbow Ecoscience. We have a session on the first day with Kelby Fight, director of Bartlett Tree Labs, coming in. So a ton of great CEU opportunities at the conference. And the day before the conference, we have a Trees in the Law workshop, which will also be a CEU opportunity. A really interesting lineup of panels on the intersection of trees and law. So if you're interested in legislation and how to have influence in your community, that's also a good event to attend. All right. Well, thank you again, Lindsay, Katie,
Thank you.
and for everyone who joined us. And we hope to see you next month. Thank you.